So today today, I appreciate y'all joining us today. Today we're going to talk about power and lighting design considerations in relation to the commercial energy code. If you have questions, feel free to raise your hand, throw them in the chat, and we'll see if we can get them answered in the process. My name is Josh Harmon. If you don't know me already, I represent the Minnesota Energy Code Support Program, which is a program created by the utilities, the public utilities within Minnesota to provide, support, educate, empower the building professionals and building community throughout the state to construct energy efficient, code compliant buildings. We're really more focused on what does the code require. We're not really pushing anywhere in one particular system, concept, or thought, but just generally providing education in any way that we possibly can and outreach to both building departments, design staff, and inspectors. So if there is an opportunity you want us to help us participate in, please feel free to reach out to us. We'd love to be there and be a support to you and your community. One of the things I always like to remind us when we start off a class is when we understand the why, then we can figure out the how. That to me is always the bigger question. You know, why do we do things? And why does the code do this? Well, the reason, the why behind it, that the code exists both at the larger level and both within the energy context, is to provide some uniform and basic performance standards for construction, right? That's the purpose of building codes, is to provide a level of control, right? We control how buildings, how loads transfer across buildings, how people use their land and develop land for through different regulatory compliance processes. The building code is no different, right? We're trying to provide a uniform, consistent expectation about how buildings will be built and the resilience with which they'll be built. And that includes understanding how we control for energy consumption, energy conservation, heat loss, illumination, interior climate controls, those types of considerations that really get more to how the building is used over its useful life than just what kind of 2x4s we use or what kind of structural members we use, right? The building code thinks about it as the traditional, we put it in the ground and it's going to be there for 30 years. Now the energy code comes along and says, okay, well, as we operate it for 30 years, what are the things that are going to be actually being used, right? When we talk about climate controls, maybe HVAC systems, mechanical systems, water heating systems, electrical controls, and that's specifically what we're talking about today, is the electrical component side of it, the power and lighting controls and considerations, more than just controls. When we think about how the code is scoped and what all applies, obviously we know we can read over it. Pretty much everything applies that we see in traditional construction, right? From new buildings, new additions, new systems, new equipment, alterations, changes of occupancy. Anytime we were expected to bring a building into compliance, then we're going to look at it from a perspective of how does that affect energy consumption and conservation, including some of those historical buildings, right? When we start thinking about, we'll have a class on historic buildings as we go through. But again, how do all those things integrate or work with energy conservation? And one of those key components, we talked about mechanical systems last time, but again, one of those key things to think about when we look at what has to comply with the energy code, it's going to be a lot of those systems that maybe get replacements, right? When we start really thinking about how is this a true like for like, or is this not a like for like, and we're really taking a 180 on the consumption associated with how the building's going to perform. I will remind you and throw this out, if you ever have any questions, remember we are here to help with your plan review, or maybe if there's some inspections that we can assist or maybe help educate. We love doing in-field stuff and coming to your office or maybe looking at a project with you online on a one-on-one. So if those considerations ever come up, you're ever looking for somebody to just bounce an idea off of, that's what we're here for, to help to do for you for free. Yes, the word free. Anyhow, digression. We'll keep moving. We don't have enough time if I make a bunch of stupid jokes. So when we think about the layout of the energy code, obviously the energy code has specific chapters, and those chapters look at mandatory, prescriptive, and alternative compliance paths. And then within their each individual chapter and section, Those main concepts address what I call the four pillars of energy conservation, which is the building thermal envelope, the mechanical systems, the water service heating system, and then power and lighting. If those four concepts are really the entirety of the energy code, what we're looking at. How does that building thermal envelope operate to maintain our conditioned spaces? How do mechanical systems and service water heating systems efficiently provide for heating, ventilation, and also hot water for our different uses, again, whether that's heating or use by the individual or business. Again, if we're looking at it from maybe an industrial application, there are different things we look at in that situation. And then, like I said, today we're going to talk about that fourth pillar, the power and lighting specific considerations. When we're going to look at it, we're going to look at it from the perspective of these three different concepts, right? We're looking at power calculations, we're looking at lighting controls, and we're looking at exterior lighting. Those are the three things we're going to be looking at. I tried really hard to look at maybe one or two different buildings, and so we're going to kind of focus in on maybe this traditional convenience store, but there's going to be a couple different examples throughout the process so we can kind of wrap our mind around what we're looking at. Remember, when we think about the first thing we usually think about when we look for energy code compliance is going to be our compliance path, right? Whether we're looking at any one of those, I just threw up new buildings as the example, whether we're looking at new buildings, alterations, new equipment, all that stuff, new additions, we're always going to look at it and say, what's the compliance path we're using? Is it the prescriptive, the energy cost, or the performance rating? Prescriptive process is that what people tell us is, give me the table, tell me what to do, and I'll do it. That is prescriptive compliance. Tell me what the table and prescribe to me the requirements, and I'll complete those requirements. That's one option, and as we see, that goes through a variety of different expectations within. Oh, you don't see my mouse moving within this group of A. So if we were to look at all the different scoping items, they would all have the same list of comply with sections 5, 6, 7, 8. 8 being power, 9 being lighting, and 10 being other equipment. Those are the three we're going to look at today. That energy cost budget path, that compliance path, is going to be looking at, again, 8.9, 8, 9, and 10, is going to be looking at how much does it cost to operate that building. This is a cost calculation. That's why it's energy cost. How much does it cost to run this building over the course of a given year? It's an annualized calculation. And there's a lot of math behind it when we start talking about how does the building operate in January versus July versus maybe September, right? And how does we're going to look into those climate zones and those different values. Again, looking at operating its requirements and expectations. So a project may utilize this compliance path to demonstrate compliance versus following all of the prescriptive requirements of the table. And what they're doing is they're complying. We've talked about compliance paths before, but again, you're comparing two similar buildings, one built to the performance path, the reference standard, and then the one that's being proposed for construction. And how do those compare when it comes to how much money it would cost to operate both buildings, given the variables in place? Performance is much the same concept, except now we're not looking at money, dollars and cents. We're looking at performance of the equipment. And those, again, are going to be softwares for a variety of different software organizations and entities to provide that this building will perform as well as or better than a building built to the prescriptive requirements of the code. So again, you have some flexibility in there in your design. A lot of people complain that the energy code is very difficult to manage, and really what it is they're almost too afraid. It's almost like when I say the word free. With training, right? Are you sure it's free? Yeah, it's free. Is it really flexible? Is the energy code as flexible as it sounds? It is actually when you think about some of the different potential paths that are available. But again, we'll talk more about that as we go about the class today. Thinking specifically about some of the amendments that were put into the adoption of the 24 in Minnesota Commercial Code, Section 8.4.2 was deleted. Now, when we get to that section, we'll talk about it. We'll remind us again that automatic receptacle control was deleted, right? To me, and again, there's a few people that jokingly I always tell them, to me, this is one of those things that it was as long as we're not controlling the coffee pot, I'm good. But in this event, we've deleted it, and so I don't have to worry about the coffee pot accidentally shutting off in the middle of my day because of automatic controls that operate based on time or occupancy sensors. Some other things that were added is the recognition that parking lot lighting is going to have to comply with Chapter 8885 of the Department of Transportation rules, right? Which we see that that's going to be the minimum efficiency standards are not to be reduced as long as we're ensuring that there's overall protection of public health, safety, and welfare. So again, it's going to give us those basic expectations that parking lots and those kinds of scenarios are going to be as efficient as possible, but not at the expense of public safety. It's probably a bad way to put it, but that's really the intent of any code, right? We want to make sure we maintain public safety and health and welfare over maybe some minor requirements. But when we look at that overall construction project, we're going to make sure that the first thing we start to think about is where is it, right? If I'm building that same specific, and again, I was talking to somebody last week, that does convenience stores and gas stations, and he does them all over the country. And one of the conversations was, well, do you evaluate for climate zones? Well, no, we kind of just build them the same way. Well, that's the problem, right? Don't build it the same way because the climate zone actually has impact. And so we can see where the state has modified the climate zone to incorporate these counties in the northern section into our climate zone 6. But more importantly, we need to know what climate zone is it going to be, and then how is space going to be conditioned within that building? Are we going to have conditioned space, semi-heated space, or unconditioned space? And then how do we delineate and define those zones in the design of our building? Now, and that also comes into a little bit of the conversation today, but that's a lot of building thermal envelope mechanical design. But it has some implication in what we'll talk about as we go through. But not only is it a question of where is it and what are we looking at as far as occupied spaces or conditioned spaces, but also what does the code expect us to provide in our submittals? And in that submittal is that electrical diagram, lighting schedule, daylighting zones, functional testing expectations. All of that's supposed to be provided at the beginning of the process so that we can do our due diligence in plan review to verify that these things exist. And so once in a while, we have to remind designers, hey, I need these. This is required information to be provided. And sometimes, for whatever reason, it's not incorporated. And so we need to always just remind ourselves that we have the authority, the responsibility really, to have these details up front so we can do a fair evaluation for code compliance. In this conversation, again, we're going to look at these different items, and this is just my little reminder to get back to what I'm talking about. And we're going to be looking at sections 8, 9, and 10. I'm a linear type of guy, so I'm just going to take it 8, 9, and 10 and show you some of this. If we were doing a little bit more in-depth conversation, maybe it would be a little bit different. But when we think about the power distribution system, what it tells us is that these distribution system, the power system itself, has to comply with the mandatory requirements of the code, right, and provide the submittal information that's needed. Now, what the actual code language says is it has to comply with 8.21 and 8.22. Well, 8.1 just told us mandatory and submittals, and then gives us an exception for IT equipment. But then 8.2 is not used, so it's blank, right? So we don't have to. There's no additional requirements to comply with Section 8. So again, we're looking at the mandatory requirements. We're making sure we submit the right information. When we look at those mandatory requirements, we talk a little bit about voltage drop, right? We're verifying that the conductors and feeders and different circuits are sized appropriately for the potential design. Again, that kind of reminds me, going back to the idea of, maybe some more mechanical sizing for distribution and load on different fuel lines, right? Same concept here. We want to make sure that we meet those minimum expectations when it comes to the types of wiring systems we're putting in place, as well as we're following the Energy Policy Act of 2005. So again, this is really not a huge thing that I've seen a whole lot of problem with when it comes to that. But again, 8.42 was deleted, so we don't have to worry about that. 8.43 is going to be electrical monitoring. We'll talk about, and again, transformers. We've talked about that already. It's very simple. That's all of it, right? So when we talk about one of those mandatory expectations, is one of them is that we have to think about electrical energy monitoring, right? Measurement devices have to be installed to where we're monitoring the use of each of these different systems, right? And that includes the total electricity, the HVAC system calculations, the lighting, interior and exterior lighting, and receptacle circuits. That energy monitoring software that has to be installed or as part of the project has to be able to record these values every 15 minutes and maintain that record for a minimum of 36 months. And then in tenant spaces, it has to provide that tenant that information. Ultimately, what this is really doing, and this is one of those things where people get, like, at least in my experience, a lot of contractors and building owners are like, why is this the code? Well, this is to make sure that the building is operating the way you designed it, right? That's what this is really looking at. And there's some exceptions, and we see the different situations when it may not be employed, maybe not in my smaller convenience store, but if we're doing a large building, we want to make sure that everything is well maintained, right? If I spend the money to buy a brand new Corvette, I want to know that it's running at peak efficiency, and I want that light to come on that tells me, hey, you're running a little lean. Same concept in vehicles that we see here in buildings. We have the technology. It's almost like the $1 Million Man, right? We have the technology. We can make them better, and we can have higher expectations about how buildings are going to perform, right? We expect them to perform the way they're designed, and that way the owner's getting everything they deserve. Again, I can tell you story after story of projects where owners thought buildings were doing things that they weren't doing, and then they're paying higher energy costs, whether that's electrical or gas related, because of inefficiencies that they didn't even know existed because they weren't able to isolate clearly where the different expenses were coming from. And so that's, again, digression, but that's the point of this type of requirement. When we look at the expectations for computer rooms, we look at, the code tells us to look at ASHRAE standard 90.4. 90.4 really requires the data center facilities like the one on the screen comply with 90.1 for everything related to the building envelope, the surface water heating system, the lighting of all these rooms that we see in this facility, except for the rooms that contain the IT equipment, the infotech equipment, right? The IT equipment. So this room itself gets an exception and follows 90.4, but as far as the building itself, it's still going to follow 90.1, right? The nature of IT facility is not changed as far as the break room, because it's an IT facility. Again, this one here is in my jurisdiction, and it was just a normal building. It's just got a server farm in the middle of it with the room for expansion, right? And so this is what's different when we think about IT to facilities. And again, they're going to follow a different standard on calculations. We could talk more about that if we wanted to get into IT one day. If you want to talk about something, let me just take a quick breather. If there is a particular topic or interest that you have, please make sure you put it in the survey so that we can develop. We really rely, I'm going to throw in this plug, we rely on those surveys and your communication to kind of guide what we do. We could talk all day about a variety of different things, but if it doesn't matter, if it doesn't make sense for what's going on in Minnesota, it doesn't help you. And so if there are particular topics or designs, maybe a building type or series of questions, please let us know. I know one that's going to be coming up that we've got a bunch of questions on that we're going to be responding to is going to be vestibules. And when do vestibules apply, especially given certain types of building designs that incorporate more doors than as a mechanism for egress versus windows? So there was a whole series of questions that was asked about that at one of our in-persons. And so we're going to develop a conversation, if not a technical document, to help with that conversation. Digression, just remember, use the survey, email us, use the website, so that we can make sure that this reflects your questions. When it comes to the power distribution system, getting back on track, we need a document that we're going to provide these types of information as far as the field testing and the commissioning of equipment to the building owner, right? How do you operate this building? How are you going to manage and maintain that energy monitoring equipment? all that has to be provided. And it's a very simple expectation, right? That everything's going to be provided to the owner at the end. And that's really what we're looking for. We also understand that except for the automatic receptacle controls that were removed, energy monitoring has to be verified, right? There has to be some functional performance testing that takes place, some type of commissioning of these equipment to make sure, again, that at day one it's operating efficiently. Again, I've got several projects I know of where equipment was not operating at peak efficiency. Control, literally, and again, I use this example. I have a theater area that a control switch was not installed per the design, right? Just a single control that would have disconnected over 50 different show lights. Because that didn't disconnect, those lights never de-energized completely, still continue to operate, running at small milliamps per every day for 10 years, right? When you calculate how much money was wasted because they couldn't properly switch them off, and then to think how that affected their actual lifespan of those devices. They all of a sudden, I got a phone call, they thought they were having a power short, when all reality was, no, you've just been running these 50 lights for almost 10 years nonstop. You didn't have a disconnect. They're still running. The fan is still running. All these, control, all these components are running. And so they're really just all giving out at the same time. You installed them all together and you just lost 20 of them at once. It wasn't electrical. It was a control issue. And so again, that's where the monitoring system can help and say, look, you're constantly running power. You only use this building, this area of your building once every week. Why do you have constant energy consumption? Again, digression, but that's the reason why we require the why behind the requirement for energy monitoring and functional testing and commissioning. When we look at lighting allowances and lighting controls, we understand that there's a variety of things that come into play. And with all those compliance paths, we're really going to make sure that everybody follows at least one of the prescribed methodologies for calculating lighting power allowances. And those are going to be either the simplified building, the building area, or the space-by-space method, right? And we'll go through those individually. Remember, the lighting installed in a building cannot exceed that allowance, and the trade-offs from different calculating methods is not permitted. You can trade off within the system, but I can't do part of the building one way and part of the building another, and then compensate for each other in my overall building allowances, if that makes sense. We'll look at maybe some of the examples that may clear that up if there's any question. Also, what it reminds us is that when we have a project that uses our energy cost budget calculation, right? When we're looking at a compliance path that chooses not to go prescriptive, but goes this other way, they're still going to have to comply with the mandatory provisions of the lighting systems, right? So again, it's not a free pass to do whatever you want. You're still going to have to do the mandatory things the code identifies for lighting itself. When we think about those, again, those are the different options. We have interior power allowances, we have exterior power allowances. And remember, we're looking at that simplified building, that simplified method, the building area, the space by space. And then we talk about, again, those for both residential and commercial. Commercial is going to look, residential, commercial, I'm sorry, interior and exterior. Interior, it's these three. Exterior, we're looking at the simplified or the exterior building calculation. Again, we'll look at those. Looking at that simplified building process, we've got tables that represent the different types of building types within the simplified system. And then within that table, we'll get the different functional areas, and we'll get a very basic calculation of watts per square foot, right? For the parking garage versus stairwells versus the office space, or all spaces other than, right? So we're going to look at these tables. It's going to tell us the type of controls, the allowances, the power calculation that goes with it based on square footage, and then that's how we would apply it, right? Again, interior and exterior of that building can go through this simplified power, this simplified calculation. So if we were to try this on our facility, right, we've got a 6,137 square foot building, right? We're going to call this a retail building, right? We talked about this as a convenience store, and that convenience store at 6,000 square foot is going to get 1 watt per square foot of allowable power, right? We then would calculate all of the lighting requirements of that interior space, right? Verify, and then that can be done either manually or through this one here I love because it used a com check. And that's what ComCheck is there for, to help facilitate these conversations. So we have all of the different LEDs that are in place that are going to be part of all the different lighting systems that will be in place. And we see the number of fixtures, the wattage of the fixtures, and the overall total wattage for the system. And the total proposed wattage is going to be 3,876, which is less than our 6,000. So ultimately, what would we say is this building going to be compliant? Yes or no? Raise your hand if you think it will be compliant. This is my audience participation based on what we see here. Okay, so not everybody's asleep. That's what I like to see. So yes, this building will be compliant given exactly what we see. It's very simplified, right? It's not asking me it's not going to do one of those photometric drawings that says, okay, where am I using the light? No, it says, here's the building. Here's how much light you're allowed to use. Show me how much you're going to use, right? Very simple. But we don't forget that there are also controls associated with it. And so for those spaces, we're going to have some expectations on those controls. These, if we're looking at that sales area, these areas are going to be reduced to general power lighting by a minimum of 75% when off hours. Again, assuming that there's off hours in certain operations within that retail space, right? Continuous daylight dimming controls in spaces that have top lighting. Again, if we're looking at those other spaces, again, we can see the different controls associated with those designs. So it's a very simple dynamic, a very simple approach to how we calculate the amount of lighting to be used in that building. And we have passed it by almost 50%. If we were to look at it from the building area method, right, so that was simplified. Moving on to building area, what we're going to do is we're going to determine that area type, right? We're going to go to the table, we're going to calculate, we're going to determine what type of building are we looking at. We're going to go back to retail, right? You can almost see that there at the bottom. Let me zoom in real quick. Right, we're going to go to retail, and we're going to see that it's now 0.84, right? That's because we recognize that the simplified building may incorporate things that aren't necessarily retail, right? And so we're going to determine the area, calculate the gross area floor area, multiply the two, come up with that value, and then we can trade off between systems. So if there was the retail space and a warehouse space, right, a storage space on that building, then I can have lower lighting expectations in the storage area than the general retail space. So again, I'm looking at that building's area, and then I'm going to calculate relative values associated with it. An example, and I can trade off between the two, right? I'm treating the building together. I'm using one methodology. Remember, if I was using two different methodologies, I can't. It's apples and oranges. But as long as I've got only oranges, I can switch between the two. I can trade between the two. Looking at this example, it's a little bit different from our other one. This is more of a school. This is a library zone. We can start to identify areas that may be qualifying as warehousing, where we're storing maybe books, versus areas used for actual education, areas that are for office spaces, areas that are being used as the library, right? So we can start to calculate different lighting demand based on different lighting area. Building areas get different lighting demand calculations. And so then I can calculate all of those based on square footage, come up to my value, and get an overall number. Now, what we saw in this one, this particular project, was they went with the simplified method. They said, let's just call this all office, right? And we're going to use 24,000 square feet of the building. We're going to give it the 0.64 square feet, watts per square foot, give us 15,000 available watts, and we're only going to use 8,000 in our proposal. This is where we start to have that conversation about you as a building official make certain decisions. Is this all going to be office? Do we think that that is an accurate description of that design? And ultimately, I think that that's that is a conversation for a longer day, right? But this is one of those places where we're comparing the design in plan review with what we see in the documents. And so if they had put down that this was going to be a retail space, I would very definitely say, no, this is not retail. This is at best, this is office within our simplified method, or in this, I would probably put this down as school university before I would call this an office space, given the fact that it's going to, again, have that type of activity going on in it. And so again, there's calculations and determinations made at plan review. And then when you get out in the field, you need to verify as an inspector, is this an office? Or is this now a warehouse that has huge lighting capabilities in a warehouse that's not going to have but 3 occupants, right? There are certain calculations, and that's the way power and lighting really becomes part of the inspection and plan review process. So again, this one would pass, but again, the calculation for building area would allow you to differentiate all of these different spaces. When we do that space by space method, we're taking even this concept and going even further, right? That's when we start to say, okay, what is that space? It's not just office space. Is it large space or small space? Is it an open plan? Is this a reading area or is this a stacks? If you think about the modern, again, I don't know the last time one of you guys went to the library, but libraries are not the way they used to be back in the 70s and 80s when I was young, right? Not that I'm showing my age, but in the 70s, 80s, and 90s, when I would go to the library, there were large stacks of books and areas where you could read. Now you're getting more to where there's less books. If you go to a Barnes and Noble, there's less stacks, and maybe more of that space, at least in the ones I've gone to, is behind the scene warehousing and storage. We're going to put a few books out, but we're not going to have, but most of it's in the back being used for other things. So again, how are we using that individual space, and can we get to where the reading area is different from the stacks, which is different from maybe the medium warehousing versus the smaller items, right? So as we see, different spaces may start to have different lighting expectations, and we can get to something that's more directly reflects the building itself and how lighting is going to be laid out. It's a design alternative, so you have all 3 options to calculate the amount of allowable power being used to perform lighting. Same concept when we apply it to the building exterior. What we're going to do is we're going to identify a lighting zone. Now, sometimes people confuse this with zoning and land use calculations, but and sometimes you can incorporate the two. But lighting zones are going to be, you're going to use the table 9.421 to designate what lighting zone, what description best represents the area of the building, right? Am I in a high activity commercial zone, or am I in an undeveloped area out in the rural areas, right? It's developed or undeveloped. And that's going to change how much light how much energy we're going to assign to exterior building lighting, right? And again, we can see this. I've got a building that I remember. It glows like a glowworm at night because of the amount of light that was allowed for it, and it's in an undeveloped farm area. And you drive by at 11 o'clock at night, and the sodium lights are on, and you can see that thing, and it's about a mile off the road, but you can see it like it's 5 feet, right? That's what the code is trying to identify. What is that expectation for lighting based on the lighting zone? And sometimes we'll allow you to be incorporated into future design, right? If you know this development is going to be commercial, it's part of a development, then you can use that different lighting zone, but you have to calculate it. So the question is, would electrical overhead heating be included in this calculation? No. That would be completely different. This is only lighting, right? This is just for task light, general lighting that we associate. Now, when you looked at and this is not to get on this digression, but if you look at the IECC starts to delineate general lighting from task lighting versus some other types of lighting. You get a little bit of that in that space by space method, but this section 9 is specifically to lighting. So the electric heating calculation is independent of my lighting fixtures. Okay, so that would be, again, that's going to be something that comes under mechanical systems. That's going to be an allowance that is not calculated in your lighting power allowances. Good question. Hopefully that answered it. But yeah, this is just lighting only. When we go back to 5 seconds, when we jump back to chapter 8, remember that's power. And in that power, we're monitoring that electric heating, but we are not restricting or identifying how much energy can be used for that heating capacity. Great question. I got to get back. So again, we're looking at the exterior lighting. So when we apply this in the field, we're going to take that area. We're going to say, okay, this is going to be a lighting zone, whatever it might be. We're going to apply that zone type to our building exterior, right? Remember, we're talking about the different components within the light within the system. So again, are we talking about parking areas, building grounds, building entrances, docks? Each one of those has its own idea of what should be used. Are we talking how much light do we need for that particular zone, right? So what we're going to do is we're going to designate a zone. This is a mixed-use residential zone. This is a new construction. They're going to tell me that that parking area is going to be of a certain size, and they're going to have a certain allowance for lighting that gets me up to 2,500, and they're going to use 700 watts of power in this design for this parking area. Now remember, we're talking, what we don't see incorporated in this is the building lighting. So I don't like to assume. I'm not a big assumer. And so this is specific to lighting. I want to see if there's building lighting. Is there decorative lighting? Is there ground lighting? Is there security lighting? What is going on with that building? Because again, that needs to be calculated into the exterior building lighting calculation. If it's mounted to the building and faces the exterior and functions for exterior illumination of the building, because architectural features, things like that, it needs to be calculated into the exterior calculation using one of those appropriate areas, right? If it's building landscaping, or again, something like that, we're using this for architectural uses, it has to be within this calculation. So we might see some trade-offs, right? We're going to have a lot of lights lighting up our really cool building. And so because of that, we have to reduce the amount we spend on landscape, right? We have to maintain that amount of space given our structure. And so again, if we go back to the one that we have seen before, I just added this because I thought that would be kind of important. So we've seen this building before. The exterior lighting that we see associated with this particular project, we have a parking area, we have canopy lighting, we have landscaping, which is included in they've used that to calculate their building This building has no real architectural features. And then also walkways. So that each one of those, they calculate the square footage of the light, of the coverage associated with it. They calculate the wattage, and then they come to a value, right? So they're able to demonstrate, here's our allowable, here's our actual, right? So that's the exterior building lighting allowances associated with lighting. Talking about the mandatory provisions, we also get into lighting controls. Now remember, we have to have lighting controls for interior spaces, parking lots, special applications, and exterior lighting controls, as well as we understand that we have to stay within our exterior lighting calculation. Talks about dwelling units when we talk about maybe multifamily that falls under the commercial code, the amount of lumens that we're allowed to have and the different fixtures associated with it. Again, parking lighting is going to be, again, focused on making sure we provide safety, but at the same, and we can talk about how we can mitigate some of those too. We need to be efficient and be safe. When we talk about interior lighting controls, again, remember, we're talking lighting. We're not talking receptacle controls. Lighting controls, we go back to the table, right? The table is going to provide us those specific requirements on the types of lighting that we need to have. Whether that's local control, restricted to manual on, restricted to partial automatic, by level, automatic day response, automatic partial off, full off, and then scheduled shutdown, right? So each, it's a little bit different in that we have to go back to these tables to find out if I'm in a classroom, in a penitentiary, what am I required? And what is at least one of my additional functions that's going to be provided? And then once in a while, you'll see where a particular space is required to have a second function in that space. And so you're required to have all these functions, and then you can pick one of these to add into that fixture, right? So it gets a little bit complicated, and we could talk about lighting controls in another class. This is more that a little bit of the higher design considerations. But again, each one of those spaces is going to have to go through. Each space is going to say, here are my different types of controls and which ones apply in which zones, spaces, that kind of scenario. And that's a little breakdown of those. But remember, at least one when we add one, and then if it adds for that second, we're going to add that second one to again as well. Same thing with parking lots. Again, we're looking for that automatic shutoff to allow us that when we see no activity, so they got to have some type of automatic shutoff that says if it's 10 o'clock in the afternoon, right, we don't need the parking lights on unless, and then you're going to have some kind of daylight sensor that turns it on and says, hey, it's cloudy, it's raining, we need those lights, then they can activate. Same thing, you're going to have that. I've seen a lot more of them as if you have technology to allow for this activity detection, so that again, if a space is not being utilized, you've seen this probably when you've driven into different parking areas or parking structures, where as you move, lights start to activate because again, they're checking for activity, not just general glow at random times. Same thing with daylight transition areas in parking garages. And again, this concept that we need to again modify and maintain the ability to dim as buildings get closer to the exterior walls, right? We don't want to create the glowworm. We don't need to keep the entire neighborhood awake with light, and I'm going to use the word light pollution, right? Most of us understand the concept of not heat island effect, but light islands, right? We start to have impacts on surrounding areas. And so especially in beautiful areas like Minnesota, I'm going to be honest, I love Minnesota now more than I did before. And there are areas where, you're going to want to shut down those lights at the Kroger, at the Walmart, because again, we're no longer needing all 500 lights on. We want to be able to see that natural beauty that exists out there. And that's what this code is really providing. It's more efficient, and it's a better thing for the overall community. It does allow us to have specific applications. So if we did have display cases and that kind of thing, then they would have those local controls for accents. Or if we were using something for, let's say, guest rooms, task lighting, devices that are controlled, just like when you go to Walmart or Kroger or one of those different food places, and you start to see that the cabinets that deactivate the lighting when there's nobody in the aisle, same concept, right? You're going to have specific applications, specific lighting associated with some of those that are going to, again, be controlled different than your overall lighting for the building. And again, like we talked about, having those daylight, some of those different automatic controls that are correct for business openings and closings, again, to allow for that architectural feature, but also at a realization that some architectural features don't need to be lit up all day long. But you do need security lighting, and those exemptions still exist for those scenarios. But again, we want to make sure that what types of lighting and how they reduce is going to be that critical conversation with exterior lighting controls. And we've already talked about that one. Again, verification and that functional field testing is going to be important to understand. Are these going to do what they're supposed to? I've got a buddy who stands literally at his business. He's the maintenance supervisor for a facility. And about this time of year, as the sun starts to go down, they operate on that clock, that circular dial for their lighting controls. I keep telling him, just go buy digital, Joe. But he doesn't. And so he has to stand there and watch. And when the sun comes down, he's watching, so he can go run in there real quick and reset the dial, right? Inefficient, right? But we need to make sure that if there's an occupancy sensor associated with something, an activity sensor, that it actually works, right? And that doesn't mean having the building inspector stand there and just wait 10 minutes to see if it shuts off. That's going to me, that's always going to be one of those reports. Like, I can do some of those when I walk into a building. I can see if lights activate in hallways, but I'm not going to stand there and stare at the sky for 10 minutes waiting for your parking lots to go out, parking lot lights to go out, unless I don't trust you, at which point then we've got a whole lot of other problems. Other equipment that are addressed in the energy code are those pieces of equipment that are, again, going to be they're going to list a few of them here. But when we see alterations or new equipment, we're going to make sure that it complies with the expectations for the building, for the energy code. That's going to address things like electric motors associated with different types of equipment, elevators, escalators, those types of surface water pressure systems. This is not just always electric, but again, we're going to make sure that there are certain types of equipment that we can monitor for occupancy and then slow or deactivate. Hope and I have been in several hotels where, we wish we were faster and able to videotape as we push the button at the elevator and the elevator lights up, right? It's been sitting there perfectly still for its 15 minutes. It's deactivated the energy associated with the lighting. There's still going to be some ventilation of the system, and there's still going to be some lighting going on. It's not totally deactivated, but at least some of that unnecessary energy is being saved because we don't have to have those lights on when there's nobody using it. Escalators, when they slow down, I've not seen one that slows down, or at least I feel like it doesn't slow down, or maybe I've never seen one that has been active long enough. But again, we want to make sure that those types of systems that are being utilized, we really think about how they're going to operate and what are those maximum expectations when it comes to, again, the lighting, the ventilation of our elevators, and those types of pieces of equipment. And again, we talk about whole building energy monitoring. We've talked about that earlier. And again, we're looking at making sure we have that type of information available to the occupant, to the owner, and that it's maintained for that period, that record retention period. Now, if it's sometime in the future the state or the organization changes that record retention, that may be something that I've seen get changed a lot. But 3 years is probably a good way to monitor. This is really going to be one of those things that's helpful to the building owner as they start to calculate, how does this affect my building, right? Especially if I'm doing updates, modifications, if I'm evaluating adding additional equipment, we know that, or additional lighting to a particular area, how much lighting am I using? Do I need to change this, or do I really need to rethink where I'm maybe occupying spaces? I worked in a building for a while where the space was disparate, or everything wasn't close together, and so I had to walk to a whole different floor to get some paperwork and come back. And every time I walked to that other floor, I activated like 15 lights to get there because of where it was located. And it just became something that, again, we didn't have monitoring this way, but it became really quick for me to understand, for my own personal, lack of desire to work and exercise, that I need to relocate the storage area because I'm using a lot of personal energy, right? A lot of personal BTUs, not necessarily watts per square foot. But that calculation can become part of that. What are we using, and is everything associated being done efficiently for both financial and workplace efficiency? Digression. But again, we see those same expectations when it comes to the size of the building, residential buildings, dwelling units, that kind of thing. Remember, with air curtains is one of those identified components, and what we want to make sure is we have automatic controls, so that when the door opens and closes, that's when it activates and deactivates. Unlike some of the, Menards and some of those places like that, where you walk in, there's an air curtain that runs 24/7 because the door's never shut, right? And so It's one of those, we want to make sure that there are controls in place so we're not utilizing energy that's unneeded or unnecessary. Again, part of this was really to bring up that some of these high level concepts so that when we do inspections, we're more aware, right? If I know that I'm looking for how a building's lighting systems were laid out, does it match? I was in a building not too long ago before where it was designed to be a warehouse, and somebody in the management decided they were going to install 2 stories of office space inside the warehouse. Well, the lighting calculations were all based on a single building, a single space warehouse. When you start adding in, I think it was 37 offices per floor inside the warehouse, you've changed the space, right? And so it was one of those, well, you guys didn't do the space right. We've got unconditioned space, conditioned space. We've got lighting issues, control issues. There's a whole lot going on. And that's part of where, as a building inspector, I'm facilitating, code compliance in that process, right? I'm saying this is not what was approved. Is it done probably right? Yeah. But more importantly, this was not approved. When did you decide to add in these 37 offices? Oh, well, that was a change order. Well, did your change order go back to the building department? Well, we don't know. If you design the building for a particular occupancy type and then they shift occupancy types, then you really do start to affect how the building is designed. What were those expectations? Are we adding more lighting, adding more fixtures? One of the things that I always do, particularly in this project that we were looking at here, when they did their calculation for this facility, there was a disconnect between what the comm check said for the number of lights. I don't know if I have that comm check in there. Right? So the number of fixtures that they listed was about 115. And the actual number on the schedule that was on the electrical plan showed 254. Well, if you're doubling the number of fixtures, that really affects whether or not you're going to be compliant with your wattage calculation, right? If we were to almost double if we doubled the number of fixtures, we'd be at 16,900, right? That would exceed the allowable wattage. And so I believe it was not intentional, but it was one of those clarifications that we sent back as a comment. The fixture count on your comm check does not match the fixture count on page E101. Please verify which value is accurate and resubmit the corrected sheet, right? That's the kind of conversation that's really going to affect how effective and how we educate the community, the design community, about the importance of these systems. I digress on that first, just on that. But again, use that information to help provide a more successful project during inspection and verification. Use your comm checks. Remember that the comm check does exist, and we've checked it as many times as we can. It looks like it works by all intents and purposes, but sometimes it's either comm check or some other type of evaluation software that's going to tell me that this performs or has the appropriate energy cost calculation. And then what you're doing, a lot of times what I see happen is people see the green bar and they say, that's great, that works perfect. Well, make sure that the areas are correct, right? Check your power allowances. Check your fixture numbers and details. Check for your controls. Is the controls identified? Are the testing parameters and control specifications provided, and where within the document? Those are important things that as plans examiners we need to pay attention to, designers, and then also that facilitates good inspections out in the field. To wrap up the conversation again, we really, when we look at these holistically, we really start to look at that series of different concepts, right? What compliance path? Where's the envelope so that I know what I'm going to be evaluating? What are the mechanical systems? What are the lighting controls? What's the lighting fixtures? All of that together is how we do these plan reviews and really look at the totality of a project. And it allows us to streamline. I think that's one of those things that we sometimes forget. You don't have to ship the book over to somebody else to say, hey, did they put in the right controls? Well, let's talk about it. Let's make sure that we're all on the same page. How does the envelope affect the lighting calculations? Well, we're looking at different spaces. Are we, what methodology do we use? Those are all important things to know in that process. Now, when you log out today, you're going to get a survey. Like I said earlier, make sure that if you've not already provided us your DLI number, or if you're an architect and have an AIA number, make sure you put that in the survey so we can update those fields and get those uploaded into the system. Make sure if you have any questions, feel free to put in, again, future topics, comments, compliments. I don't know about criticisms, put them in there, but I'm probably more focused on the compliments, to be honest. But if you just to, again, part of clarification, we do have people that join once in a while who call in. If you call in, I don't get your email address, so feel free to email us so that we can, again, send you that information, verifying that you were there and your phone number. If you watch as a team, we've had jurisdictions that sometimes watch the team, verify for us the number of people and who they are so that we can make sure we keep track of that information for you. Again, if you have questions throughout the process, always feel free to send us an email. Check out the website. Upcoming, what we'll be talking about is demystifying, again, the testing requirements, taking a moment to kind of look at some of those tests being performed on the screen and understanding what it is that the code is trying to get accomplished and why. Then we're going to be looking at more of an inspection focus for thermal envelope compliance. We're going to unveil, and you may have already seen the email, we're going to start to also do some on-site or hybrid on-site best practices series beginning in October, where we're going to take some of our technical documents. If we can schedule, we're trying really hard to schedule those to be in person somewhere, and then maybe hybrid as well. But I know some of those are just going to be virtual. But we're going to try to do some things a little different to get more involvement in the communities. But that'll begin in October. We'll get that schedule out to you. And then we'll do, again, a mechanical plan review. We're going to take a couple buildings and walk through them step by step. How are we doing the plan review from an energy code perspective, and then how does it all integrate together, right? How do you get your mechanical plans examiner to do the energy code and not pull out all their hair? And then, like I said, we'll look at alternative envelope designs, considerations, and then we'll get into some residential stuff. That's the plan, is to talk about residential, start to talk about residential in December. But who knows, we might do more. Again, upcoming on Monday is that training in North Mankato. Anybody's interested in participating, showing up, that's free, and feel free to find out the information on the website. Don't forget our Code Help support line. Again, if you have questions, remember, we're here to help you with any technical questions, provide you some subject matter expert advice. Normally, I respond to those, but I always incorporate all of the team in that response, so that it's not just me. You might get my joke more than anything, but again, it's going to be a team response to that. We did have some problems, but I think we've got this corrected. So, but then if you have any questions about plan review, we can set up, again, some classes or individual information on that. But if you have any questions, please feel free to check out our website, the Minnesota Energy Code Support.org. Email us individually, Hope or Josh at Shum's Code, whatever the email is there on the screen. We will see you. For those of you that participated in the ICC annual business meeting, we will be there. And we're also going to be at the U of M AIBO and the Region 3 trainings in 2025. So again, we're really trying to help out. But if there's anything specific that we can do to make it easier, to give you more information, please let us know. Hopefully I didn't see any questions pop up. Otherwise, order books. Dean, if you let me know how many you need and what you need, we might be able to ship them or deliver them to you. We provide free energy code books, one per I think it's per person, but we can definitely reach out to you, Dean. I'll mark you down. I know Hope's going to be in town Monday through, I think, most of the week, so maybe she can swing down. Just send me an email, and we'll either mail it to you or we will drop by. So I'll see you guys in Long Beach, or maybe sooner if we see you in person. Again, if you want to schedule something, either an in-person visit or if you want to host a training, please reach out to us. Let us know. You guys have a great week and be careful. And we will see you soon. Yeah, Dean, we might, and that might work too. So yeah, just send me. I'll email you, and we'll get the contact info.